Rosh Pinah zinc mine that the exploration department, exploration team, that needed some detailed mapping done, and they needed to understand the structure of the area because it's quite a complexly deformed area. The ore bodies are often located in the hinges of folds. The folds are non-cylindrical and they falter on the limbs, sometimes offset across the hinges as well. So they just needed to know what was going on. So I mapped in a very detailed scale, 1 to 1000. It's really nice because in this part of southern Namibia, the exposure is like 100%. So you just kind of walk around the folds and see the faults nicely exposed and kinematic indicators and everything. So it was a really cool project. You can see it's a very arid area. This is the Rosh Pinah mountain. And then there's another mountain out here to the east, and that's actually what we're going to be focusing on today. There's the Gariep belt in southern Namibia. Basically, Rosh Pinah is on the eastern margin of this belt. In grey here we've got the Gariep belt, and in pink is the basement to the Gariep. Just to locate ourselves, we're here on the west, the eastern side of the Gariep belt. Okay, so if we zoom in on the little box that was displayed in that other slide, this is a study area there. You can see the basement in pink here. And that's the Rosh Pinah mountain, or part of the Rosh Pinah mountain that I mapped, and this is what's known as the Macmillan's mountain, and that's what we're going to be focusing on today, just that portion there. So I can't remember the exact extent, but it's probably about 2 k's by 2 k's. So that's what we're going to be working on today. So it's very detailed stuff. So today's exercise is basically running through the steps of that you would follow in creating a detailed map. So if you've gone out and you've done some, it could be pit mapping, it could be just outcrop mapping, any detailed map that you've produced. Today's exercise will enable you to basically construct the map and be able to export it. Okay, so this is the geology of this Macmillan's mountain that we're going to be working on today. We have some felsic volcanic rocks in the west there. We have a sequence of arcos and argillites interbedded. It's like a turbidite sequence known as the Rosh Pinah Formation. Here displayed in yellow is a quartzite dominated sequence. There's a siltstone unit that's interbedded with that, and there's some carbonate layers within the siltstone unit as well. There's a bit of felsic volcanics sort of along the contact there. And then this unit up to the east is a diamictite. Okay, these dotted lines are the contours. So the elevation is like probably about 400 meters from the plain to the top of the mountain here. So this Rosh Pinah Formation is separated from these two formations here by quite a prominent fault. These formations here are separated from this diamictite by another prominent fault. Okay, I'm just running through the structure a little bit because we are going to digitize some of the faults, and we're going to also display some of the structural symbols as well. And I've also displayed here some of the axial traces of some of the larger faults. The symbols I've got displayed here are, I think, mainly bedding symbols and some contacts between the sedimentary and intrusive rocks, and I think there is some cleavage displayed on there as well. If we take a cross section across this mountain, that's what it looks like. The Rosh Pinah Formation, we've got this interbedded arcos argillite sequence, so nicely folded there with a couple of faults along the limbs of the folds. Then we've got quite a prominent fault, the Rosh Pinah fault, that separates that sequence from this quartzite dominated sequence, and then, like I said, we've got this diamictite unit sequence out to the east. So you can see the folding quite nicely here. So these folds are non-cylindrical. Non-cylindrical meaning that the hinge of the fold it's not kind of straight, it's basically curvilinear. So what you find is when you walk along the axial trace of a fold and you map out the the bedding, the deformed bedding, the different units, you find that, and you plot it up on the stereo net, you find that the fault plunge is going to change. It's going to be shallow, and then it's going to become steep, and then it's going to plunge in the opposite direction. So it's got that kind of geometry. So what I had to do was break up the different faults into domains, because obviously if you map out along an entire axial trace of a fault and you plot it on the stereo net, it's going to be a bit of a mess. So we'll break it up into domains. So that's what I've tried to illustrate here, is that this area, the faults are plunging towards the southwest. So for our purposes, just need to know that all the faults are plunging towards the southwest. And the inclination of the plunge of the fold varies from horizontal to sometimes 70 degrees. So there we've got plunge reading. Southeast. So here we've got pretty much horizontal folds, and as we move towards the southeast, the plunge starts to steepen to about 40, and then in some cases about 70 degrees. If we just look at a 3D sketch, that's roughly what the geology is looking like, the geometry of the geology in the area. So you've got these folds that what I've tried to illustrate here is pretty much a horizontal plunge becoming steeper and steeper and steeper towards the southeast, and then you've got these big faults that offset bedding, and in some cases the faults have exploited contacts and things like that.